All right, so thanks for the intro, and it's always a pleasure to come to Singapore. I've been here, I don't know, probably 20 times over the last 20 years. So it's a great opportunity to chat with this audience and really just share some insights that we see at CrowdStrike when we think about targeted attacks and e-crime and how the lines are blurring together. So let me just kind of go through the agenda here. I'm going to go through a little bit of an intro, talk about landscape, and then really go into attacker methods. So I'll warn you in advance, for many years with Hacking Exposed, I did all kinds of technical demos, and I used to schlep around a big case with Spark IPXs and all kinds of crazy stuff before virtualization. I don't have any demos here, and the smarter, younger guys do all the real techie stuff. But what I have lined up for you is what we see from an attacker perspective with our Overwatch team. And I think some very unique attacks that are out there. And again, something hopefully that you can take away and look at, again, what tradecraft the adversary is actually employing. Then we'll talk about kind of summary and how we go forward and how we detect and prevent some of these sort of attacks. So before I start, I always, if you've been to any of my talks, I always talk a little bit about my son Alexander. So he's 16, and he's my version of Dennis the Menace. He's always getting himself into trouble. So not so long ago, I got a phone call from the school. And they said, Mr. Kurtz? I said, yes. They said, this is the school calling with the assistant principal. And they said, we have a problem with your son. I said, what's the problem? They said, we've seen some not so good activity on the computer, and it looks like he's hacking one of these school systems. Can you come down? So I said, geez, okay, now I got a real problem on my hands. So I go into the classroom, and they tell me what happened, and I sort of apologize, and they went, I took my brow beating, if you will, and they said, Mr. Kurtz, this is just unacceptable. We can't have your son do this, and it's against the school rules. I go, yes. And they said, Mr. Kurtz, where did he learn all this stuff? And I said, well, probably his mom. So any good security guy would blame his wife. Okay, so a little bit about me. I was one of the founders of CrowdStrike. I spent 7 years at McAfee. The last couple of years I was a CTO. And then before that I had a company called Foundstone, which if you heard Mark speak yesterday, Mark Curfey, he was part of that crew way back when, and obviously one of the authors of Hacking Exposed. So if you can't sleep, the Hacking Exposed book is a good read. It'll put you right to sleep. So that was it was kind of fun when we wrote it. All right, so let's kind of jump into this when we think about the state of the nation and the attack vectors. Am I in the way here? Look at that, it's terrible. So I always like to start with, what's the impact of all of this hacking? And if you look at these two jet fighters, pretty hard to tell them apart, right? Which one is from China, which one is from the US. You can see the stars on one of them, but it's just, part of the issue is the theft of intellectual property has really kind of changed the economic game, and it's one element of the attack landscape, if you will. There's many other elements, but from my perspective, this is really driven over the last 10 years a lot of the security incidents that are out there. And we moved over the years from network exploration, right? I'm going to break into the network and figure out what's there, to data exfiltration. I'm going to go steal a bunch of intellectual property and then build, kind of a similar jet, to data destruction. And I'm going to talk about all those and the ability to monetize across that landscape. So when we think about places like North Korea, every time we have the US view of things, but every time I turn around, there's some missile that's being launched, and maybe it makes it somewhere, maybe it doesn't. But it's expensive to keep launching all those missiles. And what we've seen is nation states turn to e-crime and to wire fraud and things of that nature. And we have certainly seen some activity out of countries like North Korea. The other piece that I'll talk a little bit about here is obviously tampering with the democratic process. So if we think about what happened last year, and we were involved in doing the investigation for the DNC, it's pretty remarkable where the attack landscape is going, right? And this isn't about e-crime. This is about stealing information, potentially influencing elections. And we're seeing that certainly in the US and outside the US. So I get asked all the time, well, what happened there? And it was one of those things where we got called in, and we actually had no idea what was going to unfold after the fact. We got called in by the lawyers and said, hey, we've got an issue. Can you take a look at it? And like every other customer that we've been called on an incident, we went in and rolled out our tools and started to look around and kind of figured out that, there was, looked like two different Russian actors on the network, and the customer asked us to write a blog post, which doesn't normally happen, and we put the blog post out, and after that, it was just pure craziness of the election and, how everything went down, and was it Russia, was it not Russia, and I'm just going, hey, we're just the forensic guys, like, we just found the files, and, this is kind of what we think. But it's really amazing to see where that started and where it is today, and where it might go, and to really be part of history. I think that the key piece here, though, is this is something that the influencing of elections or influencing of people via cyber is very, I wouldn't say it's unique, but they're really honing their craft in doing that. And part of it also is then combined with kind of the fake news aspect. So if we think about a lot of countries who kind of control the news, they were able to control the news in their own country for many years. Now, with the advent of Twitter and Facebook and everything else and social media, they can actually control the narrative in other countries. So you kind of put all this together, and it's a bit of an interesting situation, certainly in the US, but I wanted to talk a little bit about that since we were involved there. So what are we seeing in terms of the attack landscape? And I like to talk about the trickle-down effect. So everybody has a phone, maybe multiple phones, and everybody probably has GPS on it. Before I got here, I turned everything off, Bluetooth, wireless. My guys are like, there's Bluetooth sniffers all over the place, and so I turned everything off. It's just a brick at the moment. But from a GPS perspective, if we think about that, that was actually built for government purposes, right? For being able to track and target different sort of apparatus. But where did that start? It started from the government, and now it's trickled down to having it on your phone. And I remember years ago, you'd have to buy a dedicated GPS device, and you didn't have a smartphone. Now everybody has it. And what we're starting to see in the cyber realm is this trickle-down effect into the e-crime space. And that's really part of the talk, is what do we see from the nation-state actors, and how do we see it trickling down? So I think WannaCry is a great example of technology that was, shall we say, leaked from some other governments, right, for the shadow brokers. But we saw some pretty sophisticated techniques, attacks in 0 days. And we saw that basically being picked up by the e-crime groups. We saw it in WannaCry, we saw it in NotPetya. And I think this is one of those areas where we're seeing much more of this. The cost to acquire kind of military grade, either exploits or attacks or kind of techniques, has dramatically come down. If we think about just 5 years ago, a lot of these techniques were out of the reach of your normal e-criminal. But because of these data disclosures, because of sort of these techniques, these quote APT techniques becoming more widely available, what we're seeing is the adoption of these techniques that started out in the nation state actually moving into e-crime. And that's part of what we're going to go through today. But it's really problematic. It used to be fairly easy to find the e-criminals, and they would just, it was just more of a numbers game. Now they're getting much more sophisticated. So if we think about e-crime, it really does go corporate. There are specific organizations, as an example, in Russia that have, 500 people in them, and they have a help desk, and they have an HR team, and they have, it's an office that they go to every day, and their job is to basically steal money. So what is e-crime? What does that all mean? The funny thing about this is, well, let me ask the question here. This is a very technical audience. How many people have bought bought Bitcoin? Couple, right? So I should have bought Bitcoin like way back when, right? I didn't realize I should have been playing that market. And I'll tell you a funny story about Bitcoin here in a minute, but Bitcoin. So one of the things that happens with e-crime is Bitcoin obviously is used for the payment. Most people haven't bought Bitcoin. Even this technical audience is not all that many folks have bought it. So when you infect the public, they have no idea what Bitcoin is sometimes, and they have no idea how to buy it. So when you look at the help desk is actually more helpful than most commercial software companies, right? It's everything from multi-language support to videos to we'll help you buy it, we'll help you, send it. It's pretty elaborate in how it actually works. So one more comment on Bitcoin, as I mentioned. So I got approached by a hedge fund recently, and they said, hey, you do a lot of these investigations and you're involved in a lot of these ransomware recoveries. Can you let us know when there's a big ransomware outbreak kind of before everybody else knows about it? And I'm like, oh, what are you interested in? I'm like, well, you know, we've been playing the Bitcoin market and we're kind of interested in that. So basically what they wanted to do is they wanted to get advance notice of when the next WannaCry hit before everybody knew it was the next WannaCry, so they could actually play the Bitcoin market and buy it in advance, because every time there's a ransomware attack, boom, the price of Bitcoin goes up. So I didn't really help them out, but that was an interesting sort of situation. So we look at market pricing. CrowdStrike, we actually spent a lot of time on our Intel team looking at the e-crime market and the pricing and how fluid it is. Here's some of the things that we found. So kind of the latest ransomware kits, ransomware as a service, everything from Dragon to Bricker to Jigsaw. You can get the pricing here, but as you can see as I go through this, it doesn't take all that much expertise, and it really isn't all that expensive to actually get in the e-crime business. And a lot of these techniques now, things that have incorporated Eternal Blue and other sort of PowerShell sort of activities have really become more sophisticated and now available to folks that maybe don't have all the sophistication, but they have the wherewithal and a little bit of money to make it happen. So you got your ransomware as a service to create the ransomware itself. Then you've got your Trojans to deliver it. Any one of these, Kins was, it came out of Zeus, and you know, you can see the pricings on some of the other ones, but it's a pretty fluid market, lots of support, and not all that expensive. And then obviously you've got your exploit kits for your browsers. So you're either going to deliver this via spam, or you're going to via exploit kit. Somebody comes in with a browser, you're going to use that exploit kit to kind of rotate through any vulns, see if there's one that might be applicable, and then deliver the ransomware itself. The last piece that you need is bulletproof hosting, and that's not all that hard to find. It's a couple $100 a month, obviously, to host the infrastructure, and off you go. So again, the point here is a lot of these techniques were very, very expensive many, many years ago, and now it's really almost a commodity. Anybody can do this. My 16-year-old Dennis the Menace, you know, he's quite capable of downloading all this stuff and figuring it out, not that he would. But at the end of the day, you don't need necessarily a level of sophistication, because it's all been brought down and made very easy. So this is one that I want to spend a little bit of time on. And when we think about companies, we always talk about data as intellectual property, right? What's your intellectual property? Well, it's all our data. It's our database. It's our customer records. It's, you know, we've got this unique formula. And that's true. It is. It's a bit of a you know, kind of conundrum in that data is your biggest asset, but it's also your biggest exposure. So we think about data as a weapon, what we're seeing out there. With the data dumps, you know, we've seen across either the political landscape, the corporate landscape, dumping data and then using that, or the threat to dump data and using that to extort money, is a big business. And we work with a lot of customers who weren't customers in advance, but they call this in for incident response, and it's the same scenario. Someone got in, someone got the data, and basically it was, hey, we're going to release all this data unless you pay us X dollars, right? And that becomes really problematic. So we see data as a weapon to embarrass and impact companies. We also see it being used to embarrass, impact, and perhaps move the stock price, which can be played on the other end from an e-crime perspective. And then we see the ransomware piece, which is, we're going to release this data unless you pay us X dollars. And sometimes they have the data, sometimes they don't, and that's kind of the hard part. So let's talk a little bit about the adversary world map. So if you know a little bit about CrowdStrike, we've got funny names for all these adversary groups. I think we've got pretty cool t-shirts with bears and pandas on them, but it's not all that funny, but it allows us to keep track of things. So when we think about some of the adversary groups that we track out of China, normally we call pandas. Criminal groups are spider, Russia as an example, or bears. Anyway, you get the point here. So we track a lot of these different groups across our entire user population in 176 countries. And we get a lot of telemetry from our endpoints, and we understand what groups are doing what and what their latest attack vectors are. We've certainly seen, I would say, in the US, maybe some of the intellectual property theft has subsided a bit over the years since the two presidents got together, Obama and Xi. We started to see a little bit of an uptick now in China activity. I think the Russian activity has been pretty active across the globe. and we certainly see them, in a lot of environments. And then you have the other groups that are out there. You've got the criminal groups, which have been extremely active. They're making a ton of money. And at the end of the day, they keep changing their techniques because it keeps working out so well. There's very little in the way of them getting caught, right? There's very low cost, very low risk, and they continue to get better and better. And again, adopt the techniques of the nation-state actors. So here's what we've been finding. We find the move to malware-free attacks. And this is one of the things that kind of always frustrated me over the, excuse me, I'm gonna drink here. It's one of the things that always frustrated me when I was at McAfee, is I looked at the industry and everybody was focused on malware, whether it's antivirus, whether it was a sandbox, everything was all about the malware. But what we started to see even a number of years ago was the fact that many of the attacks are malware-free. And in fact, a lot of the attacks kind of combine things that we've talked about in the Hacking Exposed book since 1999, in terms of lateral movement and kind of living off the land, if you will. So why are we seeing this? Well, I call it the sandbox effect. Over the number of years when sandboxes became more and more popular, the ability to identify and capture some of this malware became a bit better. And what we found is that the nation state and some of the e-crime groups were getting caught, and they moved into more of a malware-free attack model. So looking to exploit vulnerabilities, running things in memory, looking like a typical admin, kind of leveraging the tools, living off the land. Years ago in the Hacking Exposed book, we wrote about the Microsoft Resource Kit, right? I used to call that the Microsoft Hacking Kit because there were so many great tools in there that nobody even knew about, that you could just live off the land. There was no malware. All you need to do was get on and start executing stuff. So they're more stealthy, more effective, and they certainly can be combined with droppers or a piece of malware or implants. And after the implant is removed, you can live off the land. And we're going to go through some of this. So how do we know all this? So just to kind of give you a feel for what we look at on a daily basis, which gives us this information, we handle about 60 billion discrete events per day into our cloud at CrowdStrike. So to put that in perspective, if you think about WhatsApp messages or Apple messages or Snapchats or Twitter tweets, in the span of just a couple of days, we actually handle more discrete events than Twitter has tweets in an entire year. So it's a massive repository of threat intelligence and information, and that really helps us get an understanding of what the adversary is doing. And the reality is, this is a technical audience, you guys probably get this, but a lot of the techniques are not all that sophisticated that we see, and it's more of a wrap and roll, right? Where you'll take a technique, you'll slightly tweak it, slightly change the malware, but basically you're using the same kind of technique over and over again, and we see that really across the user population. Occasionally we run into some novel things, which we'll talk about here, and those are the things that kind of get our attention. And being a defender and being in this game a long time, you kind of look at some of these techniques and you have to stand back and you have to basically say, wow, that's a pretty cool technique, because it's a bit of a chess game, right? Where you go, all right, we tried to beat you, you try to beat us, and you came up with some novel technique, and kind of goes on and on like that. But that's really how we're getting this information. So we have a managed threat hunting team we call Overwatch, and they're basically looking for all these threat indicators kind of real time, above and beyond all the prevention stuff that we have. And this is really where we see the tradecraft. And if you see our threat reports or our blogs or anything along those lines, this is where we put a lot of that information out. So this is one, so I kind of broke this down into kind of kill chain steps, if you will. And the first one is around gaining access. This is a very unique one that we found in the wild. And I just wanted to go through it with you. So I think everybody's familiar with kind of the link files that are out there, right? You see a link, it's kind of like a symbolic link in Unix, but it's a link file in Windows, and it has that little arrow on it, which basically means it isn't the real file, it's pointing to the real file. So what we've seen is the adversary actually create these link files, and then a little known technique is that you can actually append base 64 encoded, sort of binary code as well on the back of this link file, and you can actually execute the code in the payload. So what we've seen is the delivery of a link file in like a spearfish as an example. You can change the icon to look like a Word icon. The only thing that you see a little different is that arrow. And most users are not all that sophisticated. They go, well, I don't know what the arrow is. Should the arrow be there or not? It looks like Word. I'm going to click on it. And then essentially what you do, and I'll come back to this, is it's hard to see on the screen here, but you actually append a complete kind of execution code into the back of the link file. So when the link file runs, it actually goes to a particular offset. When you see this get string, it goes to a particular offset and you set the length of it, and it will actually execute PowerShell off the back of the embedded link file. And I think you have like 256 different characters. So it's really cool. So you can actually just send this link file in, and then you can execute a PowerShell command, which basically acts as a bit of a dropper, and then you can execute all kinds of stuff, download files, and do all kinds of really cool things out of it. So we saw this, again, this is all like real world stuff that we come across, and again, maybe some of you run into it, maybe you haven't, but I wanted to put this on the radar because it's a very effective approach that we've seen the adversary use. When you can see the spear.doc link, and again, it's a spearfish. When you click on the Word file, the graphic, it will actually load a file up, a Word document, but then it's executing all of the code via PowerShell in the back of that link. So it's really, really cool. Has anybody seen this before? Okay, cool. That's my goal, is to show you a few things maybe you haven't seen. All right, the next one is PowerShell bypass. And what you're going to see here is a lot of PowerShell. And I mean, over the years, I used to give Microsoft a hard time. I remember, back to Windows like 3 and DOS and all that stuff. I mean, I'm dating myself a bit, but they never really had a great kind of command interpreter. And I've always been more of a Unix guy. I've always, kind of bashed on them for, well, you can't do this. There's really no scripting language. Well, at some point they got wise and said, hey, we're going to create this great thing called PowerShell, which is incredibly powerful for admin, but it's also incredibly powerful for the bad guys. And what we've seen, again, getting back to these fileless attacks, is the massive and dramatic increase in PowerShell attacks over the years. So when we think about PowerShell, it can pretty much do anything. I mean, run binary code, run shell code, it does it all. A lot of times what we see is base64 encoded PowerShell. Why? Because nobody wants to reveal what they're doing, so they kind of hide it. They try to obfuscate it from IDSs, and I have no idea what this gobbledygook means, but if you actually decode it, what you see here is PowerShell with UAC bypass. So UAC is the basically the authentication mechanism in Windows. When you want to do something, it pops up that screen and says, hey, please enter your credentials. One of the challenges that you have in the Windows system is if you think about things like Explorer is always kind of working and calling files from protected directories like System32. So if you didn't have some sort of whitelisting in Explorer as an example, every time you went to go do something or browse a file system or the operating system was actually calling System32, it would just pop up an annoying prompt that says enter your username and password, right? So that would be totally distracting. Nobody would want that. So there's an interesting suite of tools. You can see them here, is PowerShell suite. But basically, you can impersonate the Explorer shell, and basically that is whitelisted in terms of what directories can execute. So instead of prompting you to enter a username and password, it basically is whitelisted by the operating system. So if you call this UAC bypass, here's the command. It will go out and basically get it and run it. It will run, and essentially what it does is it actually calls a command shell with admin privileges. So when we think about getting on a system, and I always love when Microsoft comes out with stuff where they go, hey, this is not a problem, it's not admin, it's not, it's really not that bad. Well, of course you have to chain all these things together, right? You have to get on the box and you have to escalate privileges. In this particular case with UAC bypass, you can actually impersonate the Explorer shell, and then you can kind of steal that token that's used to access protected file systems. So you can run things like in this particular case, you can see the command shell which is running, which is basically started with privileged access. And you can also run programs that are in there if you want it, aside from command shell. So it's a really popular and powerful way to bypass the user access control within Windows. And I think this worked up until Windows Creator 1. I think update 2 or something actually fixed it. But it is a very effective way to get admin if you're on a box. And that's always been, my approach. Even if there's the smallest sort of vulnerability on a system, which again, Microsoft might play down, where they say, hey, this is not admin, it's not as bad as it really looks. If you get on the box, there are many, many ways to actually escalate privilege. This is a very effective way, okay? So, let's look at persistence and exfil. This is an interesting one. This is one where we're doing an incident response. And the customer basically called us in, and they were fairly sophisticated. They had an issue, and they said, hey, we went through the right steps. We kind of identified, what we thought was the malware and the adversary. We went through, we kind of we thought we got rid of everything. And then we did a remediation where we reset all the passwords, and the bad guys keep getting in. And we're just confused, and we've gone through this remediation. We really followed all the right steps. We thought we put them out of the network. We thought we got rid of everything. And, like on a weekend, they literally shut everything down and reset all the passwords. And, next week these guys were in there. So they were just scratching their head trying to figure out what happened. And they called us in and they said, okay, well, we got to get these guys out, and we just can't figure it out. So this is what we found. You can see again, this is base 64 encoded using PowerShell, using Mimikatz. And actually, this is a really cool technique, leveraging Microsoft OneDrive with this command. So if we actually decode this command, what we see here is PowerShell. Again, this sounds familiar, right? PowerShell. Going out and basically getting Mimikatz and then running Mimikatz. So it pulls it down, it runs it. It then connects to Microsoft OneDrive using SSL to encrypt itself. You can see the SSL session here. Puts a username and password. These are burner sort of accounts, right? And then copies Mimikatz, the output to this drive. So basically what they were doing is they were, I think it was a VB script, they were appending this base 64 encoded PowerShell into the startup scripts. So every time the machine started or somebody logged into the system, it would basically dump all the credentials and put them in a file, and then using OneDrive, it would actually just use a net use command and move those off into OneDrive. And then they would come back in. They didn't have two-factor authentication on their VPNs, and they would come back in, or they would get to their email, and it was sort of wash, rinse, repeat. So it was a really cool technique that we found. And again, wanted to pass it along to the group here, because some of this stuff we hadn't necessarily seen in the wild, and I think it's good for everybody to kind of figure out what's going on. You could see the VB script there that was actually running as part of kind of the startup script. So they had no idea it was there, and that was really a big part of their problem. This is actually just a graphical display when we ran our tools on there. You can see all of the services that are running, and then you can see PowerShell being invoked, and you can see the two net use commands. So when you look at the process tree, it was actually pretty easy to kind of figure this stuff out, but they had a hard time dealing with it. Okay, so the next one up is this malware download. So using a word macro lure to download malware via Microsoft Bit Service. So the Bit Service is the service that's actually part of Microsoft, right? So when it does updates, it actually has a trusted service. You can download files. The interesting thing about the Bit Service is that it's actually whitelisted within the Microsoft firewall system. So if you want to download software and files, this is a great mechanism. So again, using something like a spearfish, you can actually embed these commands into kind of a Word document, macro commands, and then once this is executed, it will actually go out and using the Bit Service, which is now whitelisted in the Microsoft firewall system, it will actually then call PowerShell again, and then download the code that you're interested in actually running on the system. Again, this is a very effective way to bypass a lot of IDSs. It's an effective way to bypass firewalls because a lot of the bits sort of update software is kind of whitelisted all over the place. And this was something that was exploited very quickly by the e-crime groups that are out there once this came out. So again, just give you another idea in terms of malware downloading capabilities via macros. All right, Chopper Web Shell. Anybody run into Chopper Web Shell? Okay, so Chopper Web Shell. This is what I love about sort of the entire industry that is focused on malware. You look at this thing and you go, okay, what the heck does it do? I can tell you as an example, you can take this 72-byte script here and try to upload the virus total. It's not going to flag anything, right? It's not a piece of malware. And that's part of the issue that I've seen, is that the whole industry really has been focused on stopping malware rather than stopping a breach. And I always ask the question, are you more interested in stopping a breach or malware? Most people go, well, I want to stop the breach, right? Malware is just a piece of it. So Chopper Web Shell actually has a pretty cool client component to it. So if you can exploit via SQL injection or some other mechanism, kind of a web service, web server, or database, whatever, however you get on the system, you can put up a web shell. And basically the web shell in this particular case runs as, it's an ASP page, and it basically will allow you to execute any code on the web server itself. So it has a corresponding client, and the client can upload files, can download files, you can call a command shell, you can do whatever you want, literally with 72 bytes. So people look at this and they go, I mean, there's no malware, there's no virus total detections on it, how do you find this stuff? And we'll talk about how you find this stuff later, but this has been, this Chopper Web Shell is used by the Chinese all over the place. Again, this is another example where we got called in from an incident response perspective and people couldn't figure out what was happening. And when we rolled out our Falcon tool, I mean, we found Chopper Web Shell all over the place, right? So this is one of those areas where if you have a web server, you need to be looking for these web shells. Chopper is just one of them, but running and executing code via ASP or running it and executing out of your SQL databases is a very common technique that we see, again, across nation state and e-crime groups. All right, so the last one is sticky keys. Anybody here are sticky keys? Maybe a few? All right, so sticky keys, this is really cool. This is, again, it's a similar story. This is a different client that called us in, and they had the same thing. They were battling a group that was in and out of their network for the better part of a year, and they kept resetting all their passwords, and it was just this constant issue. And when we first got in there, we weren't sure if they had sort of a golden ticket theft. And if you guys aren't familiar with that, golden ticket is the Kerberos authentication that works within Windows. And if you steal a golden ticket, I mean, the thing is good for like 10 years, right? So you have just a massive issue trying to get people out of there and reset everything. So anyway, we went in there and again, rolled out the tools and got some visibility, and quickly we realized what the bad guys were doing. So there's something called sticky keys. And I'm a pretty impatient guy, so when I log into a computer, I'm banging the thing and trying to get it to wake up from sleep and hitting the shift key and doing all that. So I hit it so many times that it pops up this accessibility. You ever see this accessibility screen when you're impatient? And it says like, hey, do you want the on-screen keyboard? Do you need help? Do you want us to read, some of the text there in case you're visually impaired? So they have this concept of sticky key. And basically what they've done is they've modified the registry, you can see it in the first command here, to call a debugger and then call a command shell. And essentially what they've done is when they were on the machine, this is a command that they actually ran, they actually then modified the on-screen keyboard. Instead of calling the on-screen keyboard when you hit the sticky key, so you have to hit shift 5 times to get the sticky key. When you hit shift 5 times, this box pops up. And instead of, when you click the button, instead of calling the on-screen keyboard, it actually calls a debugger, and the debugger calls command shell. So you don't even have to log into the system. And that's why they were so confused, because they were looking through access files, and they were looking for users logging in, they were looking at all the normal stuff, but they didn't realize that the system had been compromised and this backdoor was left as part of, the toolkit of tradecraft of the adversary. So this is very, very effective. It's good for your teenager if they don't give you the password for their computers. You can put that on there, right? It'll allow you to get back in once you're on. And it runs as system privileges. You can see it right here in the screenshot. So very effective backdoor. Again, if you're sweeping for malware and you're looking for IOCs and you're grinding the file system and you're just looking for kind of malware that might be a backdoor, you need to look at some of these other techniques that are out there that I think are very clever. And when we saw this stuff, again, being on the defensive side, you look at it and go, okay, that's pretty cool, right? That's really a clever technique of how to create a backdoor. So that's sticky keys in action. All right, so moving along, what other e-crime trends do we see out there? Certainly, I think the Eternal Blue and the Shadow Broker dump has been the gift that keeps giving to e-criminals. I mean, there's just a ton of information in there. People are still trying to unpack all the vulnerabilities, all the exploits, and we're going to see more and more of that. Things that have taken millions and millions and millions of dollars to develop over many, many years have now hit the market. And, it's like somebody dropped a nuke somewhere, and, people are going, oh, that's how you build one, right? I mean, it's, you kind of bring some of the stuff that was very hard to figure out down to the masses. We certainly see spam bots leading the malware distribution kind of effort over the exploit kits. It's so easy to get spam and people to click on it. I mean, we've done some testing where, we pretty much sent fishes into companies, basically said, hey, this is malware, don't click on it, and you got like 50% click-through rate. So, it's like, do not click, and people still click on it. So you can get in pretty easily doing that stuff. We were involved in supporting the takedown of Helios botnet, which I think has been pretty cool and effective in putting a dent in e-crime. And then what we saw, this CVE 2017-0199 was, this was an exploit that was, I think it was HTA. It was the kind of HTML combined with JavaScript within Word, where you can actually execute HTML, embedded HTML and JavaScripts, and then pull down files. And we saw a lot of different attacks by e-criminals once that vulnerability was actually released. So, NotPetya. Anybody get hit by NotPetya? Anybody admit to it? No? Okay. You guys really must be hungover from last night. So NotPetya recovery. I'm not sure if you guys have seen this, but we actually, on the CrowdStrike blog, we actually figured out a way to basically decrypt the master file table, if you will, if a machine actually was encrypted by NotPetya. So there's still multiple phases of trying to get other files back, but at least kind of get the machine up and running. So this was interesting. We did a bunch of work here. Salsa 20 was the cryptographic algorithm that was used for the master file table. It uses different sectors and numbers, and it basically tries to compute a key for the encryption. And through a combination of known plain text and many time pad attack, we were able to actually kind of recover it and then use that to decrypt it. So if you want more info, there's a very technical blog that our guys have done. It's on the CrowdStrike blog site. I'm not going to go through it here, but I think it's really cool, really good work by the team in actually being able to kind of recover some of those systems. And there's still systems out there that people are looking to recover. It's been a massive impact. So changing the game in cybersecurity. So those are kind of all the bad things that we continue to see out there, and what we thought were some unique things that we wanted to share with the audience here. So now that we went through kind of all the badness, what are the areas that can help as a defender deal with some of these challenges? And the two big ones are graph and artificial intelligence. So if we think about graph and how graph works, basically it's a kind of a tree node system. But graph has the possibility to really help drive detection and prevention without ever seeing the attack sequence, or the attack, malware as an example before. So a good example is if I didn't tell you anything about a particular file, and the file started to execute, it started to enumerate the file system, it started to delete the backup copies, and then call an encryption routine, depending on the provenance of the file, yeah, it could be an admin tool, but very likely this is a piece of ransomware. So by using graph technology, you're able to really map all of these discrete events very quickly into not a relational database, but a graph database. So you can walk the graph and figure out via stream of events what's good and what's bad. And we see this really as a pioneering technique in security, and one of the areas that's really going to help drive adoption of dealing with this massive amount of data. It's one of the areas that we're helping to pioneer, but there's others that are doing it as well. But it's really that attack sequence. So what does that mean? It means that I can change the malware, I can change the PowerShell, I can do all that stuff, but the effects are still the same, right? I still need to run system code and programs. I still want to dump credentials. I still might want to encrypt the file system for ransomware. Like the behavior, the end effect is not any different. It's just a method to achieve that. So if you can map this into a graph format and look across the stream, it actually becomes very easy to detect and prevent against these sort of attacks. So graph will be a major force going forward. And now with a lot of the graph technologies that are out there, open source and others, you kind of, again, bringing this down to the masses. So question for the audience here, hopefully you guys are not too shy or too hungover to answer this. Do we know who painted this picture? Any guesses? Actually, it was Rembrandt. So, but it was like 100 years after he died, or 200 years. It was recently. So essentially what happened, this is really cool, is that there were a group of college, I think it was a university that put it together. They literally looked at all the Rembrandt paintings that were out there, and they extracted all of the features of how he would normally paint something. And they put that into an artificial intelligence model, a machine learning type model, and basically they recreated a new Rembrandt exactly the way he would have painted it. So if you haven't seen this, it's worth taking a look at on the internet. So they looked at how he painted, where, you know, eyes and nose and kind of features, and I mean, it's amazing. So this was actually created by a computer, but it was driven by all the prior Rembrandt paintings that were out there. So this is kind of the future of artificial intelligence, and one of the areas where, from a security perspective, being able to, again, predict what's good and what's bad, right? We're looking at kind of a 3D plotting of data points. This is actually a simple one. This happens to be, this isn't even security, this happens to be male and female anatomy, right? Just sort of bone structure and height and weight and those things, and the size of the wrist. And just with some, really 3 points, you can see, you know, where the females and where the males basically break out. This is a very simple example, but being able to plot many features in a three-dimensional space and then determine whether something is good or bad is really kind of the next phase. And you can do this both in a supervised, hey, I have a bunch of malware that I'm training, or unsupervised, I'm looking at a bunch of data and events that are happening in my environment, and I'm looking for deviations from normal. So AI is certainly here. And when we think about AI, many years ago, it was kind of a bad marketing, it's still a marketing term, but you had two phases that were really just failures, and now we have the third evolution of it. And with the advent of cloud computing and large data sets and things like Google TensorFlow, AI capabilities and algorithms and computing power become available to everybody else. So let's put it all together and try to summarize. You know, when we think about all these kind of issues that we went through, how do we find the bad guys? How do we prevent them? The cloud is going to be a really important part of that, you know, having telemetry and understanding what the bad guys are doing. And it really becomes a race to understand what they do very quickly, you know, and be predictive as well. And the cloud is going to play a big component of that. And we're seeing more and more cloud adoption just in general, and certainly from a security perspective. The second one is around threat intelligence. And, you know, understanding, we talked a little bit about IOCs and threat actors, but really understanding the tactics, techniques, and the procedures of what the bad guys do is really important for protecting your organization. You know, finding a piece of malware and understanding whether it's targeted or not targeted is really a critical element into how you respond to something. If it's commodity malware, you have one response. If it's targeted and it's by one of those groups that I mentioned earlier, you're probably going to have a long day, a long week, and leveraging threat intel and sharing of threat intel at network speed is going to be important. And the last piece is, I don't know how many folks have their own sort of dedicated hunting team, but that's really been, you know, become much more popular, where you've got, certainly have your response team and you have your pen test team, but then you have a dedicated team, and all they're doing is hunting for the adversary on the network, right? So who might be on the network? Maybe it's an insider, maybe it's somebody from the outside, but being able to, you know, jiggle the doors and, like a sentry, figure out if somebody's on the network and make sure that your incident doesn't turn into a data breach or a major catastrophe for you. So with that, I will wrap up here. I think we've got probably a minute or so for questions. Does anybody have any specific questions for me? We've got a mic here. Okay. No questions? It's a shy audience. So I want to thank you for coming early to the presentation, particularly on Friday. And it's always a pleasure to be here. Thank you for the invite. And if you have any questions, I'll be available after the conference presentation here. So thank you so much.
Thank you very much, George.